I am Kyriakos Kritikos. I'm a researcher at ICS4, and today I'm going to present to you CAMEL, which is the cloud application modeling and execution language that is being used in the CloudSocket project in order to support the BPaaS adaptive provisioning. So here how I look like. Some initial things about this webinar. First of all microphones will be muted for all the attendees of the webinar. I will present the webinar, and then after I finish, then you can type your questions in the chat window in your webinar controller, and I will be happy to answer them. This is the agenda of a webinar. First of all, I introduce to you what are the features of CAMEL. Then I will move on to explaining how CAMEL is being used in the CloudSocket project. I will indicate what is the current tool support for CAMEL. I will then provide some initial concepts covering different aspects in CAMEL. I will move on to the modeling of a particular use case, a particular BPaaS. Finally, I will provide a summary of the webinar, and in the end, I will be happy to answer any questions that you may have. So, moving now to the features of CAMEL. So, CAMEL has been developed in the context of the BPaaSes project in order to support the model-driven development of multi-cloud applications and their management. So, it has been developed as a multi-purpose multi-DSL, which integrates a set of DSLs into a coherent whole. And each DSL covers in different aspects. So in this sense, CAMEL is able to support many aspects, including requirements, deployment, provider, organization, and so on. CAMEL has not been developed from scratch, but it reuses existing languages which have been either developed in the context of the BPaaSes project, or they are already available as standards. It caters for the models at runtime support, and especially the type instance pattern, where at type level you can have, let's say, the topology of your application and the requirements and its requirements. And at the instance level, you can have the actual snapshot of the application of BPaaS and how it evolves over time. CAMEL, and especially its respective tool support, enables the validation of the models conforming to CAMEL, and both the tactical and semantic manner, via the use of the combined use of EMF and OCL. So in this sense, let's say the semantics of the different aspects of domains are well coupled. Okay, so here you can see some existing languages from which CAMEL has been developed. So CloudML has been used in order to cover the deployment aspect, SRL in order to cover the metric and the scalability aspect, WS agreement in order to cover the requirement aspect, Saloon to cover the modeling of the providers, and Serif to cover the modeling of organizations. In this table, I indicate what are the different types of CAMEL models, what do they cover, who is responsible for providing them, and whether they should be they are generated at the design or runtime. First of all, I would like to indicate that CAMEL model is a kind of container which includes different types of models inside it. So at the top level, we have the CAMEL model, as I said, which is a container of other models, and in addition includes some general information about the current application or BPaaS. So let's say this model, of course, is being provided by the broker, and it's been developed and updated at both design and runtime. And the deployment model covers the topology of the application. So what are the components of the application of BPaaS, how they are connected to each other, how they communicate, and where they are deployed. And the type level is covered by the broker himself, and the system level and the instance level is also covered by the broker, but the system is responsible for updating the deployment model at runtime. The requirement model covers different types of requirements: hardware requirements, PaaS requirements, security, location, and so on, and is mainly provided by the broker at design time. The metric model covers the modeling of metrics, so which let's say are used in order to specify different measurement aspects for a particular attribute that has to be measured. The modeling of sensors, which are used in order to provide measurements for those metrics, and conditions, which are, let's say, constraints over the values that the metrics can take. The type label for the metric is being provided by the broker, and while the instance level is being provided, is being actually updated by and created by the system. So let's say the broker interference is at the design design type level, and while the system interference is at the runtime level. Concerning adaptations, the adaptation model covers adaptation rules, the modeling of composite events, and the modeling for adaptation actions. And this model is being provided by the broker at design time. Locations can be physical or cloud-based locations, while physical locations, let's say, specify area locations that cover continents, subcontinents, and countries, while cloud locations are usually hierarchies of cloud-dependent locations. These locations are used in order to specify requirements over virtual machines or PaaS that can be used by BPaaS, and they are provided by the broker at design time. The units are units of measurement, so the unit model covers different units can be specified by user, the broker at design time, while the types model covers some particular types or values, where the types can be used in order to specify the value type for a particular metric. And this type model is being provided again by the broker at design time. The organization model covers the modeling of organizations, their users, roles that are involved, and the policies which map roles to particular actions that can be performed on respective resources of the corresponding platform, and also cloud credentials which can be used in order to deploy a particular BPaaS on behalf of a user. A provider model covers provider offerings which can be both at the ES and PaaS level, and this usually is a kind of model that is being provided by the administrators or the operator, let's say, of the let's say CloudSocket platform. And this model can be used to, let's say, can be specified at let's say design time, but can be updated at runtime if there is a kind of updating mechanism injected into the platform. And finally, the execution model covers, let's say, the conceptualization of execution context, which is a kind of, let's say, a particular deployment episode for a BPaaS. And this execution context includes information about which measurements can be produced, which SLOs have been satisfied or violated, and which adaptation actions can be performed in order to sustain a particular service level. And this execution model is being produced automatically by the system at BPaaS runtime. So as you can see from this table, we have many models that can be specified by different actors, but the broker mainly has a subset of all these models to specify in the context of a particular BPaaS. Now I'll move on to how CAMEL is being used in the CloudSocket project. And I tried, let's say, to cover the whole BPaaS lifecycle in my presentation for this. So in the beginning, we have the BPaaS design environment here, which provides a BPaaS design package, which includes the modeling of BPaaS workflow, the KPIs for the BPaaS, and some DMN rules. And this BPaaS design package is being used as input to the BPaaS allocation environment, which also takes into consideration a registry of components and services, and attempts to produce the best possible allocation for the BPaaS based on the respective requirements specified for it. This, let's say, allocation is being modeled in the form of BPaaS model, which mainly includes a CAMEL model. And this CAMEL model comprises, let's say, at least a CloudML deployment model covering the deployment of the BPaaS, a set of adaptation rules covering the adaptive behavior of the BPaaS, and a set of SLOs or KPIs covering the, let's say, the service level that should be executed by the BPaaS. This BPaaS bundle is then published in the marketplace and can be purchased by BPaaS customers. And once a purchase has been made, then the BPaaS bundle is being sent to the BPaaS execution environment, which then is split into its three main parts that are being exploited by different components inside that environment. So the deployment model is being exploited by the cloud provider engine in order to deploy the BPaaS. The SLOs and KPIs and the WSM agreement part, let's say the requirement part, are being exploited by the monitoring engine in order to deploy the monitoring infrastructure and be able to obtain measurements that can enact the adaptation of the BPaaS if needed. And this adaptation is being handled by the adaptation engine, which takes into consideration the adaptation rules that are being specified in the SRL part of CAMEL. The CAMEL model that has been deployed in the execution environment is also exploited by the BPaaS evaluation environment in order to be transformed into a semantic model, which is then input in a particular semantic knowledge base, and via this, let's say, semantic lifting and storage of the CAMEL model, and in particular the SLO, KPI, and metric part, then the respective evaluation of KPIs can be performed by the BPaaS evaluation environment. So actually, as you can see, CAMEL covers 3 out of 4 environments and respective lifecycle activities of the BPaaS. Some small details about the technical underpinning for CAMEL. So first of all, it relies on Eclipse and especially EMF with respect to the specification of the meta model part of the language, and which in conjunction with the OSCL let's say, rules can be used to specify also some semantic domain rules for the semantic validation of the CAMEL models. So EMF plus OCL covers the abstract syntax of a language, while the XTeX technology is being exploited in order to cover the textual syntax. And this syntax is then, let's say, being realized in a particular editor which enables a DevOps-based, let's say, editing of CAMEL models. Now move on to explaining what is the current tool support for CAMEL. So as you can see in this comparison table, we have 4 main editors, which have different characteristics spanning the capability to validate the models, to cover different aspects in CAMEL, to be able to update and store models in a respective repository, model repository, to have access, control access to the models being stored and all their parts. What kind of format of CAMEL is being supported. So there are 2 main formats, XML and textual, where the latter one maps to the textual syntax of the language. What are the roles that can be involved in editing of the CAMEL model? And finally, the last column indicates the respective technology that has been used to realize the editor. So we have 4 entries. The tree-based editor is a default editor provided by the Eclipse environment by default, which supports model validation and the coverage of all aspects and repository integration. And it also enables some control access over the models if the respective, let's say, administrator of the system has been involved in the specification of particular roles that can be used in order to edit that model. In the underlying, let's say, separate part of the model repository. This editor supports XML format and can involve any kind of role. The textual editor, which has been developed via XTeX, supports the validation of models and all aspects, but it's being used in offline mode, so there's no repository integration for it, and of course there's no meaning for the access control. This editor enables to edit textual models But when you save these models, then you are actually producing also an XML version for them. And this editor has been used mainly to cater DevOps users and the way that they would like to develop, edit and develop models. There's a graphical editor which has been developed in the context of the BPaaS project, which supports model validation and the coverage of requirements of this aspect, very well integration with the repository, and let's say full access control on models and their parts, and both formats of CAMEL and any kind of role, so DevOps or administrator, and has been developed via the Eclipse Wrap technology. But as you can see, it's very limited with respect to the coverage of the CAMEL aspects. And finally, we have a graphical editor which is actually used in the CloudSocket project by the allocation environment, which supports model validation and covers mainly the requirements, metric, and deployment aspects. It has an underlying repository on which models can be stored, and it supports control access to these models, both formats of CAMEL, and has been mainly, let's say, developed to cater for the DevOps role, but attempting, let's say, to let's say cover a different, let's say, way of editing models for this kind of role. And finally, you can see that this let's say editor relies on the live-based product. Now I'll move on to some, let's say, presentation of the main concepts involved in the CAMEL language, and I will mainly, let's say, introduce only and cover particular aspects of CAMEL. So mainly the CAMEL top layer, and then the deployment, requirement, and scalability aspects. So starting with the CAMEL model, as I said, it is a top-level model in the CAMEL specification, which includes some models focused on different aspects, and it provides some high-level details for the cloud application of BPaaS. And these details cover the name, the version, the owner, and the reference to deployment models for this cloud application of BPaaS. Here you can see, say, a depiction of the meta model of CAMEL for this part. So as you can see, you have the CAMEL model as a main class, which is related to the respective models via containment relationships. So you can see there's connection with requirement, metric, deployment models, and so on. Now, moving to the deployment model, the rationale for this model is that it has to specify most information which is needed at the type level for deployment reasoning and at the instance level for deployment execution. So this model covers actually the topology of your application of BPaaS, and this means that it specifies what are the internal components of the BPaaS embedded configuration, what are the VM nodes and requirements on them on which the components can be deployed, what are the PaaS service nodes and what are the requirements on them, and are exploited by the, let's say, the BPaaS, what are the SaaS nodes and the requirements on them, but are getting exploited by the BPaaS, what are the hosting relationships between components and VMs and components and PaaS services, and what is the communication between components, so the component-to-component communication. So this is actually what the deployment model covers. Here you can see a snapshot of this deployment meta model, where it focuses mainly on the coverage of the PaaS, let's say, level in the cloud stack. So a PaaS can be considered as an external component which can be used in order to support the hosting of an internal application component of a BPaaS. And this PaaS is related to a PaaS requirement set which can, let's say, enable the matchmaking of the available PaaS providers. And this PaaS requirement set is related to a PaaS requirement which can be, let's say, a set of options for different characteristics of the PaaS, like the pricing type, the upload type, the subs type, and so on. And a reference to a set of requirements for the underlying visual machine that will be, let's say, handled by the by the PaaS in order to deploy the BPaaS component into a corresponding user machine. So these two types of, let's say, information can be used in order to select the appropriate PaaS that can be used to deploy a particular internal component of a BPaaS. And apart from this, let's say, extension of CAMEL, which has been done in the CloudSocket project, also you can see that there's on the top part and top left part of the image, you can see also the new way that configurations can be specified for components. So a component can have multiple configurations, but now apart from a script-based configuration, we also enabled a component to have a PaaS-based configuration, which let's say which enables the model to specify less information with respect to a script-based configuration. I would like to indicate here that also the instance level is being covered. So one PaaS, let's say, node will be mapped to multiple PaaS instances at the instance level, and the same will hold for the internal components of the BPaaS and so on. But also, I would like to indicate that the PaaS level has been introduced in order mainly to support a faster deployment of BPaaS components, because let's say this was considered as a very interesting, a very important requirement in order to support BPaaS adaptation. Because if you want, let's say, to move one component of the BPaaS from one user machine to another one, then AES-based adaptation will take approximately 10 minutes, or PaaS-based adaptation will take approximately 2 minutes. Now move on to requirement model. This model can be used to specify different kinds of user requirements, and in addition, it enables to specify logical combination of requirements using let's say, very well-known and or logical operators, binary logical operators. And there are two types of requirements that can be specified: hard requirements or soft requirements. Hard requirements should be let's say, satisfied by all means by the CloudSocket platform, while soft requirements are just indications that the platform should do its best effort to support this requirement. And soft requirements mainly cover, let's say, optimization goals over functional properties of metrics like BPaaS, let's say, duration, while hard requirements have different subtypes. So have hardware requirements where the user can specify ranges of visual machine characteristics. We have PaaS requirements where the user can specify different a set of options, alternative options for different PaaS characteristics. And location requirements, what is a set of allowed location for a particular PaaS or visual machine. OS requirements, what is the operating system that should be used to host a particular BPaaS component. What should be the set of providers that can support say, the deployment of BPaaS components. Security requirements, which are specified in terms of high-level security controls that should be realized by the CloudSocket providers that can be selected for providing infrastructure support to the BPaaS, and service level objectives over manufacturing properties or metrics. Here you can see a visualization of the requirement meta model, part of CAMEL. So a requirement model is a set of requirements. Requirements can be grouped via the requirement group conceptualization, which relates a set of requirements to particular logical operator, can be AND or so on. And so as you can see, requirements can be soft or hard, and then you can see that the hard requirements can be hardware, provider, OS, and so on. There can be location, security, and service level objectives. Soft requirements can be optimization requirements. And there's also a different kind of requirement that was mentioned in the previous slide, where you have scaling requirements. So why do we need these requirements? The main reason for introducing them is that they restrict the way that the BPaaS can be scaled. So horizontal scale requirements will indicate that a particular BPaaS component can scale, let's say, from 1 to 3 instances, while a vertical scale requirement will indicate that the VM hosting a particular BPaaS component can scale from, let's say, 2 to 4 cores for 2048 to 4096 amount of RAM memory and so on. One of the main, let's say, extensions of CAMEL has been developed in the CloudSocket project is the adaptation model, which can be considered as an evolution of the original scalability model. So the main rationale for this adaptation model is to drive the BPaaS configuration via specifying a set of adaptation rules that will drive the BPaaS adaptation behavior. These rules map one event to a particular adaptation strategy or workflow. Events can be simple non-functional events which map to certain metric conditions, while composite events are, let's say, a composition of events which are, let's say, which employ logical and time-based operators. And the adaptation strategies or workflows are usually specified in the form of a composite adaptation task, which can include inside it a set of single adaptation tasks which cover different abstraction layers. So here you can see, let's say, a particular depiction of the adaptation meta model. So you can see that we have on the top an adaptation rule that maps an event to a particular adaptation task. Adaptation tasks can be composite, and there are 4 different kinds of composite adaptation tasks. We have parallel, sequential, conditional, and switch. Conditional adaptation task relies on a particular event which should be satisfied not to perform the adaptation action, while a switch adaptation task is a kind of switch where we, let's say, we evaluate a particular expression, and based on its value, we will execute a set of different adaptation tasks, simple adaptation tasks. And as you can see, for the simple adaptation tasks, we can have, let's say, different kinds which relate to different levels. So we have, let's say, the workflow level covered by the workflow recomposition. We have the ES level covered by scaling adaptation actions, so both vertical and horizontal scaling. We have task modifications which cover task addition, task omit, task replacement, and so on. And we have service replacement adaptation actions which will be used to replace one service with another one. So this, let's say, ends a short presentation of CAMEL with respect to its meta model. And now I'm going to present to you a particular use case and how this use case can be modeled in CAMEL. So this use case involves the send invoice BPaaS, which is a support business process that has been realized in the form of a business process as a service. And this, let's say, BPaaS requires the execution of 2 main SaaS, a CRM SaaS and an invoicing SaaS. The CRM SaaS, it's in the current decision making of the broker, will be realized via an external SaaS. So a particular external SaaS service, while for the invoicing functionality, there are different deployment options. The first option is that we are using Invoice Ninja as an external invoicing SaaS. The second option is that we are using Invoice Ninja, which is exposed as an internal SaaS component offered by the broker. So it's a kind of, let's say, multi-tenant SaaS offered by the broker himself. And finally, the third option is an Invoice Ninja exposed as an internal SaaS component, which is dedicated solely to one client, which can be, let's say, a bigger one with respect to the clients covered by the option 2. So in this use case, I will try to cover the third option. And now I'll move on to the way that CAMEL will be used to model it. So in this figure, you can see, let's say, the deployment model of CAMEL. So the invoice needs a software component will provide a particular communication port 880, which will be used in order to accept, let's say, requests from outside world. And this invoice needs will be component will be hosted in a particular virtual machine called M1 small on the stack, which is related to a set of particular virtual machine requirements. This component will also communicate with a MySQL database, which provides a particular communication port and is being hosted to a different virtual machine with different sets of requirements. In addition, well, let's say the first figure here indicates to say that the normal type level, which are going to support in order to deploy the BPaaS. The second figure mainly covers, let's say, again the type level, but an optional, let's say, part of deployment, which will be enacted when we are trying to adapt the invoice needs a software component. So this alternative part, which will also be specified at type level, the invoice needs a software component should be hosted on a PaaS which is named BPaaS. It's related to a particular PaaS requirement set, and this requirement set is related to a particular PaaS requirement and the same virtual machine requirement set as the one for the let's say EAS service that will be used in order to host let's say originally the invoice and software components. So the PaaS requirement covers some particular, let's say, features of the PaaS. So its status is that it is in production mode. It supports Java. It supports CloudSocket as a platform, and Java EE as a framework. Finally, one small detail is that in the deployment model, we also cover, let's say some particular allocation decisions which relate to the service level. So, let's say if we are using a particular SaaS service, then we need to specify also to which workflow tasks this service is being mapped to, because this information will be used in order to, let's say, adapt the BPaaS at runtime. So, for example, perform service replacement. So we need to know exactly to which, let's say, task a particular service is being used to realize the functionality, as we need to replace it with another service. So for this use case, apart from the hardware PaaS, OS, and location requirements, which can be already specified in the previous figures as part of a VM requirement set or PaaS requirement. And also, the requirement model of this use case will also cover the specification of SLOs. So the first SLO will indicate that the mean response time for the invoice needs internal service component should be less than 10 seconds, and that the mean availability of this service should be greater than 70%. And finally, there will be one adaptation rule be specified in a respective adaptation model of CAMEL. So this rule will map one event to a particular action. This event indicates that when the invoice needs a SaaS component availability is very low or its response time is very big, so map it, let's say, to a evaluation of one of the two SLOs that will be specified in the required model. Then you have to perform a composite adaptation task or workflow. So you have to deploy the invoice needs a SaaS component via PaaS to a new virtual machine. Once this is done, then you have to update the service endpoint in BPaaS workflow to point to the new location of the component, and you have to delete the old invoice needs a virtual machine. So in this sense, we actually move, let's say, the component from one virtual machine to another one as the current virtual machine is problematic, and we are employing a PaaS-based deployment to do this move, because, as I said before, this deployment is generally faster than EAS-based deployment. Some small details about the BPaaS adaptation architecture, but I guess that additional information will be provided in the next webinar, which will cover the cloud creator, so the cloud orchestration component of the execution environment in the CloudSocket platform. And in this figure now you can see that let's say the CAMEL model of this use case will be used to feed the monitoring adaptation and cloud provider engines. And originally the cloud provider engine via SWORD will orchestrate this internal service component to an OpenStack virtual machine. And while this, let's say, this virtual machine and component will be monitored by the monitoring engine, particular events will be produced by the monitoring engine and will be given to the adaptation engine, which will then detect that the adaptation rule specified is triggered and will first, let's say, do the pass-based orchestration. So we'll use the pool library from Dangers to orchestrate the pass-based deployment of the component to the Heroku pass, and then we'll perform the service replacement by contacting the workflow engine to change the workflow specification temporarily for the BPaaS, and then then the adaptation engine will request the undeployment of the virtual machine at the ES level, and again SWORD will be used in order to do this undeployment. So this ends my today's presentation. So I have introduced to you CAMEL as let's say a language which can be used to specify many aspects and drive the adaptive provisioning of BPaaS and BPaaS workflows. This DSL covers many aspects in different domains. It covers both IaaS, PaaS, and SaaS levels. It's explicitly is able to model cross-layer adaptation rules. It has a very good support level because it's supported by various editors that enable to edit, validate, and store CAMEL models in model repositories. This language is being used and further extended in many European projects. It has originally been developed in BPaaSes, but now it's been exploited in CloudSocket and Melodic, and it was also exploited in the Cactus project, which has ended some months ago. And in addition, there's some possible standardization option for CAMEL, and especially with respect to Tosca. And there's a particular group, the incubation group has been formulated, which will try to create an extension of Tosca to cover the instance level based on the information that has been boarded for this level by CAMEL. So this ends my presentation. Thank you very much for attending my presentation, and I will be very happy to answer any questions that you may have. I will wait for 1 or 2 minutes, and if I don't see any question, then I will end this webinar. Okay, so it seems that I don't see any other questions being posed. So thank you very much for attending this webinar. I hope you say now have a better view of what is coming and how it's being used in the CloudSocket project. And I would be happy to also let's say have you in the next telcos that will be held the project. And the next one, the next one is the one about the cloud creator orchestration tool, which is being exploited by the CloudSocket platform. Thank you very much. Bye-bye.